Hi, Srini, how are you? How are you, my friend?
Hello,
How are you?
I'm fine, sir.
What do you do in the morning?
Seeing your video for chapter 5, lah, sir. So many hours, lah, sir. But the chapter
So,
5,
chapter 5, Chapter 5,
9
okay.
hours, sir.
9 hours, I didn't realize that so long. Okay.
No, like
Anything?
the other early topic each like 5 hours, okay. Now like 9 hours. So like I so far went until interference can understand, lah, sir.
Okay, anything you want to clarify?
No, so far no, sir. Oh, sir, by the way, right, sir,
Yeah,
the exam, right, they did delay it.
they did delay. So when is the final exam?
Not next week, next week.
Delay by 1 week lah.
Mm.
Give you more time to study, though. Since we cannot finish our past year paper if we are going to do by topic. Okay, let's go to topic 20, wave motion. Okay, if you look at the past year exam paper book, you can see that what is more popular? What is more popular? Can you see that?
Wave intensity.
Yeah, you see that? Wave intensity is popular. Electromagnetic wave only very rare lah, but just come out lah. Okay, let's carry on. Right, you need to know how to represent a displacement distance graph. What is the wavelength? And what is transverse wave? What is longitudinal wave? How to draw it? And that's the essential one. V equals to F lambda.
Teacher, can you just give me 30 seconds, sir?
Say again.
Just give me 30 seconds, sir.
Okay.
Hello, sir.
Okay. Let's carry on. And know how to write the equation for wave moving the positive x direction. This one. More common is the sine one rather than the cos one, but it's also possible to come out. Then know this equation. Right? Phase difference. Basically, this is 1 2 pi lah, 2 pi 1 circle lah. This is your lambda, right? They are directly proportional. And also same thing, t over period. All this equation must be in your head, and then know what is k. K is 2 pi lambda. Omega is 2 pi f. And then intensity power over area. The area is the surface area, 4 pi r squared. And then intensity is proportional to amplitude squared. So if you combine these two equations, then you get AR equals a constant. And principle of superposition. What is the principle of superposition? Right, remember that. And then know particular what is constructive interference, what is destructive interference. And then sometimes they will give you the equation, but you have to sometimes remember the equation, this equation. And then know your standing wave in string. Right? This is the first one. There's the node, there's antinode, node. Right? Antinode is the largest amplitude. and then know how to derive all these equations. Then condition for standing wave. Right? Both waves must travel in opposite direction through the same medium. They must have the same speed, wavelength, or frequency, same amplitude, same time. That means sound wave and sound wave, electromagnetic wave and electromagnetic wave. Then using this equation, we should be able to get that one there. Right, for standing wave. And then for standing wave in stretch string, right, F1 is the fundamental, this one. Fundamental is V or lambda 1. And then the higher harmonic will be F equals to N F1. N is 1, 2, 3. And then that is the equation to remember. The speed is determined by the tension in the string and the mass per unit length. And then equation for electromagnetic wave in terms of electric field or in terms of magnetic field traveling in the positive x direction. And then C is just square root mu epsilon naught mu naught. That's the electromagnetic wave. And this is your electromagnetic spectrum. Maybe memorize the first thing here. Right? Gamma ray is more than 10 to the power 19. X-ray is 10 to the power 16 there, more than 10 to the power 16. Ultraviolet 10 to the power 14. And visible is about 10 to the power 14 there. Then infrared is 10 to the power 11. Microwave is greater than 10 to the power 9. Less than 10 to the power 9 will be your radio wave. How you memorize it? Okay, what's the answer for this one? A wave motion has an equation that where x and y are in meters and t in second, which of the wavelength and speed of the wave? That is the equation that you should know. What's the answer? Yeah, use the standard equation. That's the standard equation. There's your lambda. That's your frequency. Can?
Okay, donkey. The answer is donkey.
Let's see. Right? This one is traveling in a positive direction. Compare with the standard equation. Your K is that's a K 4 pi. And this goes 2 pi over lambda. So cross multiply 0.5 meter. And omega is 2 pi f. That's your 2 pi. That's your omega. And from there, you can calculate divided by 2 pi. It's 100 hertz. And speed is f times lambda 50. Okay, good. How about number 2? A progressive wave on the string is represented by the equation that where x and y are in meters and t in second. What's the speed of a particle of the string at 0.1 not meter when the time is 4.0 second? Differentiate it to get the speed. Got the answer?
C.
Say again.
C.
Too soft, can't hear. Never mind, let's go over. Turn the volume louder. Right, same. That's the equation. Differentiate it. dy dt. So it's 0.25. Sine become cos. Then you differentiate that one. becomes 500. Then put in your value. Their distance and that time there. But remember, you have to convert it to radian before you calculate it. The answer is C. Good. Okay, how about number 3? The speed of wave in a stretch string depends on
Donkey.
okay, good. That is the equation. Donkey. Number 4.
Sure.
Yeah.
The term 2 one, they are not postponing. So do you suggest like I study the SEM 2 one also one shot right now?
Yeah, you better start already. No time already. You
Okay.
have to start already. No time already. Okay. Number 4. The equation for progressive wave is given where y and x are in meters, t in second. What's the speed of the wave? Yep. What is the answer?
Boy. Che, can you go number 3 back, Che?
Now 3 is just as equation as well. You memorize the equation.
Number 2, Che.
Number 2. Right? Number 2 is the vertical
Okay. That's all,
velocity. Right? Compare the standard equation. Right? K, there's your K. Find your lambda. Then omega. Omega is 2 pi f. So in this case, omega is 20.
Divide by pi.
And multiply. There's your frequency. There's your lambda. So lambda. Pi and pi cancel off. Okay, B. Next one, you need to know. Okay.
So lambda, where you get 0.5 answer.
Lambda is from here. There's your lambda.
Sorry.
Don't convert it. Don't convert it. Convert unnecessary because the pi will cancel off. Unnecessary calculation. Just leave the pi there at the end there, then you can calculate out. Okay.
Okay.
Right? You need to know
Okay,
all these maths. Okay. How to add them up? Okay. 2 identical progressive waves, each of them with amplitude A and intensity I0, but of different phases, are shown on the graph below. If the 2 waves superimpose, which is the phase different and the intensity of the resultant wave? This one a bit more challenging now. A lot of maths involved.
Yeah, this one I'm not sure.
This one just is a standard equation for the waveform. Okay, you simplify it. No need to just, that is your sine curve. This one sine curve for the dark line. Right, call that your y1. And then y2. Y2 is just you start amplitude 0.5 A. And then you want to find the phase. That's your phase, just add it in there. and then 0.5. 0.5, work it out. 0.5 is half. Half is 30 degrees, right? Half, sine half, sine theta equals to half. You let your x equals to 0, the x equals to 0, then you can calculate your theta or phi, whatever you like, whatever symbol you like to
Pi
use.
over 6. Yeah.
So you get 30 degrees. 30 degrees is pi over 6. So that theta is pi over 6. Can.
So, but why you do sine kx plus pi over 6 equals to another sine kx plus theta?
Oh, this one is just to, basically the best way is to put x equals to 0 lah, in this case, because that's what is happening at x equals to 0. That's why it looks so confusing. Sorry, I think I better remove it. Let x equals to 0. No point in making it so confusing. Right? At x equals to 0. Right? That's what the graph tell you. When x equals to 0, you have that is your, where it starts with, your y value. So let x equals to 0, then you can, x equals to 0, then 0.5, right, or half is equals to pi over 6. So theta is pi over 6. And y2, right? So y1 is this one. We have calculated this one for y2. Add these two together. Y1 plus y2. Don't worry about this equation, WT, because you are working with x only. No need to worry about time. Okay. Then you get that equation. Then intensity. Intensity at x equals to 0. Your intensity is y or A2. Right? Your x equals to 0. Your amplitude, you look at, you put into this equation, because this is a resultant displacement. So your x equals to 0. And then that's why you get, calculate out. You get 1.93. Then we're just using this equation, I over amplitude square equals to constant. So this is a new one. This is the old one. Right? You want I2, so take A2 square across. So I0, that's where we start with. I0, I1 is I0. And then the amplitude is A. So now we want to find our new amplitude. There's a new amplitude. Put it in there. Calculate out. You get our I2. The answer is C. Okay, a lot of calculation involved here. A bit more challenging. Anything that's not clear?
Wait, I just want to.
Speak a bit louder, can't hear you.
Oh, 1 minute, sir.
Okay.
Just want to understand. Okay, so the y1 is the sine curve, the dark one, right?
The dark one, that's the y1. Y2 is a broken line, broken curve. That's your y2. Then add the two y1 and y2 together. You get this equation.
Y2 is the broken one, is also a sine curve, right? Sir?
Yeah, it's a sine curve.
Okay.
With a face. Don't bother to change it to another cos curve. Right? Use sine curve. Just have a face as well. A sine curve with a face as well. Sine curve with a face.
Oh. 1 second.
Just treat it as a math problem.
Nah, macam copy.
Okay. Need more time?
Okay. No, done.
Done, okay. How about this one? A point source produces spherical waves. The power emitted by the source is 0.8 watt. What is the intensity of the wave a distance 2 meters from the source?
Oh, intensity formula.
Yeah, intensity formula. What is the answer?
Where are you?
In case you are looking for the formula. The intensity
A,
formula.
answer is A.
Answer is A. Let us see. Your power, that's your power. And then your distance, 2 meters. Okay, good. Number 7. A transmitter radiates energy uniformly in all directions at a distance 50 kilometers from the source. The amplitude of the vibration of air molecules is given this amplitude. If there is no energy loss to the surrounding, what is the amplitude of vibration 30 kilometers from the source? Okay, what is the answer?
C.
Right? Yeah, I memorize the formula. I work it from the basic 2 formula. Sorry, something went wrong. Okay, you're right. Right? Well, this is 2 formula. And then we can see that AR is constant. And there are other ways of calculating. As I said, I prefer to use this way. I don't have to worry about 4 pi or that. Then I want to find a new one. This is a new one. This is the old one, original one. Then take the R2 down and put in your, this is your R1.
So how you made AR equals to constant? No?
Say again.
How you did AR equals to constant? No?
These two combined. Replace this I with that. KA square.
Oh.
Then take the R square up. R square and A square is equals to constant. Others are A square and R
Others
square
got
are
value,
variable.
others are
The others are
different.
constant. Then just square root it. Square root is still a constant. Can?
Oh. Can?
And put in your value. This is your R1. This is your R2. No need to convert to meter because these are the two same unit. And then this is your A1. Okay. Anything not clear?
Okay.
Number 8, intensity of a wave at a point 2 meter from the point source. That one there. What is the intensity 3.5 meter from the point source? Can?
Yeah, can.
What's the answer? Take all the variable to one side, take all the constant to one side.
A, the answer is A.
Right? P is your constant. Pi, for pi is constant, take r square across.
Yeah, so
And this
IR
is the new one.
equals to constant.
This is the original one. This is the original one. And put in your value. I1. That's your I1. R1, R2. R1, R2. Okay, square that. A, okay. Number 9. Intensity of sound wave at 3 meters from the point source is 20. What is the intensity?
Go back.
Go back.
Okay.
Intensity of sound at a distance 3 meters. Right? Almost the same thing. Almost the same way of doing things. What's the answer?
Boy.
Right? Same as previously. Okay, good.
So wait. Okay.
Right? Can use this equation to calculate B. And then after that, use this equation to calculate at that distance, same thing. Right? Whichever you prefer. Two similar progressive waves traveling in opposite direction with wavelength 1.0 meter and frequency 50 Hz and amplitude 0.2 meter respectively. At distance t equals to 0, the displacement at x is 0. What's the expression for the resultant wave when the two progressive waves superimpose? Ken? What is the answer?
Answer is boy.
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 There's a equation for one, general equation. Right? Both traveling in opposite direction. Add them up. You can memorize, go ahead, but I won't encourage you. Encourage you to derive it. Then know what is K. Right? K is 2 pi over lambda. That's your lambda wavelength. And omega is 2 pi f. Right? 2 pi, that's your f. Is 10 pi. Then go back to our equation. That's our equation. Put in your value. Amplitude is how come the amplitude is not given? Oh, 0.2 times 2 is 0.4. And then omega is 10 pi. That's what we do. K, here's your K, 2 pi x. C, okay. Any comment?
So actually, you know how I did or not? I thought it was like straight away like can form the equation because they already give the clue. I didn't know like you have to jump over the thing.
That was lucky, though. That you get the right answer.
No, I put boy, I didn't put C.
You put boy. Oh, okay.
Yeah. No, because they give the amplitude, they already give the omega find
Amplitude is
I get
double
10
because
pi.
you add all of them together. The amplitude must
Yeah,
be double.
careless mistake. I didn't see two similar progressively. I thought it was one.
Okay. I suppose
Yeah,
you can
one
guess
minute
also
answer.
like if you know the equation rather than derive it.
Yeah, but I got wrong also.
Okay. Any
Where are answer?
Okay. 11. Which statement is true about standing wave?
Boy.
Right? There's your standing wave in string. Points on the nodes are maximum wrong. It should be antinode. Node should be 0 amplitude. Points between two adjacent nodes are points between two adjacent nodes. Okay, true. All the points between adjacent nodes are vibrating in phase. Every point in the wave has the same amplitude. No, right?
Nope.
These are all different amplitude. The largest one is here at the antinode. Points on the antinode have the highest frequency, not highest frequency, highest amplitude. Frequency is constant. Frequency doesn't change. Right? For a particular mode, frequency is constant. So answer is B. Can? Okay, how about number 12?
So go back number 10, please. Number 10.
Number 10. Yep. Any comment? Anything not clear?
Clear, sir. Okay, can continue.
Okay. That's the answer. When a particle is at maximum displacement, a standing wave on the string is shown in the diagram below. If the period of oscillation is t, what is the waveform of the standing wave after 1/8 period? Yep.
C.
Say again.
C.
No. This is where you start. Right? So when it goes down to here, it's a quarter. When it goes down to the minimum, another quarter. So when come back there, another quarter, then go back another quarter. So altogether, one full period. Oh. So 1/8 is between here. Right? All this you must know. Let me just get rid of the. Okay, there's your 0. And then that's a quarter. And this is your half. And 3/4 will be here. Period will be down there. Okay, answer is B. Okay, number 13. Which statement is not true about mechanical and electromagnetic waves?
Go back, sir. Teacher, which one is T equals to pi T over 4?
T over 4 is the center one, this one. At the center, this one. T over 4. A quarter, from there, from the top to the rest position is a quarter. A quarter to the maximum, to the minimum position is another quarter. And from the minimum to the rest position, another quarter. And from the minimum position, from the rest position to the maximum is another quarter. Okay, so it's go from maximum to rest position, quarter. Then after that, it goes down, will be another quarter, which is now half. Then when it comes back to the rest position, another quarter, so it's 3/4. Then when it goes back to the top, there is a period, the full period.
Teacher, your mouse not moving, I can't even see.
I'm showing you on the screen now the picture. Why is it move the mouse?
No, the thing is like not moving. I can't see.
I'm not using the
like
mouse.
stopping.
Unless you cannot see my picture.
I can't see the picture.
How come funny? Right? This is your where you start. Then go down to the rest position. There's your period. There's a quarter period. Then go to the minimum, another quarter period, which it becomes half a period. Then as it goes up again to the rest position, you will get another quarter, which is 3/4. Then it goes back to the maximum. It becomes a period. Just like that. Maximum, 0, rest position, a quarter of the period. Then to the minimum, another quarter of the period. Then goes back to the rest position, another quarter period. Then to the maximum, another quarter, which is a complete period.
Okay.
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 Okay, number 13. Which statement is not true about mechanical and electromagnetic waves?
Not true. C. No. C is correct. C is correct. A. The answer is A.
Right? A is false. Sound wave is longitudinal wave, thus cannot be polarized. Right? So mechanical wave depend. You cannot use unless you say it's water wave lah. Okay, but since you say sound, you say mechanical can be sound wave. Mechanical and electromagnetic wave can undergo interference and diffraction through. Mechanical waves can be longitudinal wave or transverse wave. That's what it has to be lah. But electromagnetic waves are transverse waves through. Mechanical waves require a medium for propagation, but electromagnetic waves do not require it through. Right? Answer is A. Good. Okay, what is there to learn from here? Not every year will come out lah.
Very rare it comes out for section B.
Right? Popular would be standing wave lah. You can see there. Standing wave.
Okay. Oh, Che, by the way, right, Che, because my my class teacher, he predicted, not predicted lah, he see all the like trial paper for this year. Everything is like chapter 1 coming out in section B, so it's confirmed lah.
So how do you do your trial exam?
Bad. Everybody did bad. Only like 2, 3 only pass.
Huh? So bad lah.
Yeah. Chemistry and physics especially.
Chemistry and physics bad. How about the other subject? Okay.
Maths also bad. PA only everybody was like passing.
General paper okay lah.
The other papers all bad.
Oh, okay. Let's put more effort. Okay. A string with one end attached to an oscillator of frequency 30 Hz and the other end to a mesh, that's the other end, over a pulley produce a standing wave as shown in the diagram below. Describe the formation of standing wave in the string. Yeah. Ken?
Two identical waves traveling opposite direction.
Okay.
They superimpose producing resultant wave. They have node and antinode.
You have to relate it to your picture. So the oscillator is the one that sent in the incident wave. So incident wave got reflected from the fixed end, the pulley. So the incident and reflected wave interfere. Okay. So oscillator send the incident wave, the incident wave and the reflected wave. The incident is reflected at the pulley. The incident wave and the reflected wave having the same speed and amplitude interfere to give standing wave with node at the pulley and the oscillator at the end of the string. Okay. Determine the wavelength. Wow, how to determine the wavelength? Yeah. How to determine the wavelength?
Determine the wavelength.
Just look one side.
Yeah.
From 0 to 0. From 0, there's a maximum, and then to 0, what is it? Wavelength, half a wavelength, 3/4 wavelength, or quarter wavelength? Right? This is only half a wavelength. That's half a wavelength.
Half a wavelength.
40 cm
So
is half
3
a
over
wavelength.
2 lah. 3 over 2.
Right? Half a wavelength is 40 cm. So wavelength is just times 2, 80 cm.
Wait, then the others one, teacher?
They didn't give you the value. You must always go back to what they have given you. Right? They give you this part only. So you must focus on this part. This part is half a wavelength. Right? They didn't give you the whole length. So you cannot use 3/4 lambda. Right? Focus on this part. They have given you the value. Okay now.
Okay. So they want it in meter or centimeter?
Doesn't matter. Doesn't matter. Cannot mark you wrong. You can put cm, you can put meter. It's up to your choice.
Okay.
Calculate the speed. So speed, you need the
V
wavelength.
equals to F lambda. 30 times 80. In this
Then
case, I just
determine
put
the
meters,
mass per
so
unit length of the
24.0.
string. Mass per unit length of the string.
V equals to square root tension over.
Yeah. That's your V. Right? Subject of mu. Square it. Take the mu up. Take the V square down. Put in your value. Okay.
Okay. So can you go back for A?
A, you need to say that the oscillator is the one that sends the wave. And then it's reflected at the pulley. And this incident and the reflected wave have the same speed, same amplitude, so they interfere to form standing wave. And that at this end of the string and at the pulley end of the string, they are stationary, they are not. That's all. Okay, need more time?
Yeah, just 20 seconds. I'm already there. Okay.
Okay, let's carry on. State the three differences between progressive and standing wave. And remember,
Can't remember.
progressive wave, all points vibrate with the same amplitude at different time. No points on the wave are permanently at rest. Phase of neighboring points are different. For standing wave, amplitude is maximum at the amplitude is maximum at the what am I doing? Maximum at the nodes. Between successive nodes, the amplitude at each point differ. Sorry. Amplitude is maximum at the antinode. Between successive nodes, the amplitude at each point is different. At nodes, the displacement are permanently zero. Right? There's no nodes here. Between successive nodes, all the points vibrate with the same phase. Right? These are the points vibrating at different phase. Okay. So must be committed to your memory.
Yeah.
The equation of progressive wave is given, where x and y are measured in meter, t in second. Determine the speed of the wave. 4 marks there. How to determine the speed of the wave?
Speed of the wave.
Yep.
V equals to F lambda, but then before that, I need to find omega. Omega equals to 2 pi F, so omega is 4. So 4 divide 2 pi, you get the frequency.
Right, go to the general equation.
Yeah.
Get your K. That's your K.
Get the lambda at the same time.
K is 5. And then
Equals to 2 pi
your
lambda.
lambda.
Yeah.
After that, get your omega. That's omega is 4. Then calculate your F. Right? F is 4 divided by 2 pi. Cancel by 2, we get 2 over 5 and use
So
your
4
V.
over 5.
That's all.
Yeah.
Okay.
Or 4 marks just like that. Okay.
Each step of the wave are probably 1 mark here, 1 mark here, 1 mark there. I don't know where is the other mark.
No, I mean free mark if this kind of question comes up.
So we don't know how the examiner will give the mark. Unless they give you the mark for what the equation itself, just general equation.
Okay. Okay.
A standing wave is formed by superposition of two progressive waves in B with the reflected wave from the end where the string is tied. Assume there is no loss in energy. Right? They give you the formula. State the principle of superposition. Yep, can remember? Yep, can now. These are all by your must be by your friend.
When two waves meet at a point, the resultant displacement is equals to the sum of individual displacement.
Okay, when two waves cross or meet, the resultant displacement is the sum of the individual displacement. Okay, deduce an equation for standing wave form.
Y1, Y2, 0.020 sine, 4.01.
To be able to write the equation down. Y1, right? We have already obtained that. Then Y2, then add Y1 plus Y2. That's what you get.
I want to ask you, when you plus Y1, Y2.
Yep.
Sure.
This is your,
when you plus
this is your
Y1,
A.
Y2.
This is your A. Sorry, this is your A. This is your B.
No. What I want to understand is that why when you sine plus sine, then you get cos. That's why I don't get it.
Say again.
Okay. Now mind. I understand. I get it. Nothing.
This one is one. This one is one. This is one.
I understand. Now I understand.
Determine the amplitude of the standing wave at 0.45 meter. Yep.
0.040 cos 5.0x.
Right? That's amplitude. And put your value of x in 0.025 meter. Okay.
Teacher, this is when t equals to 0, right?
Say again.
This is when t equals to 0, right?
Don't bother about the t. T is not the amplitude. T is how it changes with time, how the amplitude changes with time. So amplitude is just forget about that one there. You get 0.4 cos 5x. Then put this one must be in radian, not in degree. Right? 0.45 put inside there. Can or not?
Can.
Then the last part you should be able to do. Determine the minimum length of the string used. How to do that? Yep. How to determine?
Lambda equals to 2 pi over k. So k is 5, so 2 pi over 5.
Lambda is 2 pi over 5. L is lambda over 2. Right? This one, go back to your previous. From here. Right? There's a lambda that we have calculated there. That minimum is just at the fundamental mode. No? Fundamental mode is half lambda, one loop. Just that one there. One loop there, just one loop there. One big loop there. That's the fundamental mode. So that's your minimum. What am I doing? Can or not?
Okay, sir.
That's all. Put in the value of lambda inside there. The lambda inside here, then calculate out.
Oh, okay, understood.
Okay, let's carry on to number 2.
Last question.
Right, same. Just choose any of these. This one is in the note that I've given you. Right? Remember DAP, that's all. Energy doesn't move along in standing wave, whereas in progressive wave, the energy move along with the wave. Right. Two wave P and Q traveling in opposite direction along the stretch string are represented by the equation given you. X and Y are in meters, T in second. These two waves superimpose on one another to form standing wave with a second overtone. Sketch the pattern of waveform for second overtone. Yeah, second overtone. How many loops are there? Yep, how to sketch?
The node, antinode, node, antinode, node. Just draw the.
Yeah, how many loops are there?
How many loops? Second overtone means first frequency something, right?
Yeah, you can draw on the whiteboard. Yeah, can draw on the whiteboard there.
I can't draw.
Huh? You can't draw. Use your mouse to draw, cannot.
Cannot.
Oh,
Trying, cannot.
let me see what I have done. What should I do?
Yeah, you disable the screen sharing.
I disable the screen. How to enable it? How about now? Can try? Draw it. Use your mouse to draw.
No. Nope. No, cannot.
Huh? Cannot. How come?
Yeah.
What should I do? Okay, should be able to draw now.
No, cannot.
Funny. What should I do?
Only you can draw. You have to allow me to share screen, teacher.
I allow you. Yeah.
No, you never allow yet.
This one is disable, nothing for others. So I allow you.
That still host disable participant screen sharing. Not yet come yet.
Try again. Still cannot.
Still cannot.
Funny lah. How to enable? I enable you. You still cannot. Never mind. How many loop?
One loop, sir.
No lah. Can be one loop. Second overtone is third harmonic. Third harmonic is 3 loops.
Three loop.
Yeah, that way. That's how you should draw. Derive an equation for the standing waveform. That one no choice already. I have to use your maths idea. That is your equation that you want. Right? That one, the maths you have to remember. Right? So add these two together. Right? The 2 is here, and that is your amplitude.
Yep.
And then add, this is your A, this is your B, A plus B, A minus B, and then you get
So
that equation.
sine 2t cos 8x. Yep.
Can?
Can. Understood.
No choice, your course is a lot of maths involved.
Yeah, exercise lah.
Calculate the amplitude of the standing wave at 0.2 meter. So you have to derive first, and then you can calculate.
Why not substitute first, teacher, at x equals to 0.1?
Okay? Don't worry about the t when you want to calculate amplitude. Right? That's amplitude. Then put your value of 1.02 for x. Inside that, remember this is in radian. You get that?
Yep.
Can?
Yep.
Determine the distance between two consecutive nodes of the standing wave. How to do that?
Um, 2 pi over lambda equals to 8.
Either you put your A equals to 0, because your node is where your A equals 0. So A equals to 0, your cos 8x equals to 0. So 0 can be, right? This one is your math already. It can be cos pi over 2 or 3 pi over 2. And from there, you can calculate your x and subtract to get your nodes. Yeah, subtract the distance, get a node. Or use your k is 2 pi over lambda. Right? You get your k is 8. That's your k. So your distance is lambda over 2. So as long as you get you can calculate from here lambda. Okay, can? Then determine the two possible value of x for position of antinodes of the standing wave. Right? Antinode, remember, you want this one to be A, this A to be 0.030. Right? That's amplitude. That's why I put 1 here. And there's your math problem now. Right? Where this is equals to 1, it can be cos 0 or cos pi or cos 2 pi. And from there, you can get that. Okay.
So why you do cos 8x equals to 1? I don't understand. What's the question about? I don't get it.
You want the antinode, two possible value for x for the position of antinode. Antinode is where the amplitude is, this amplitude is 0.030. That's why I put 1.
Okay.
Right? 0.03 cancel that, becomes 1. So 1 is cos 0 or cos pi or cos 2 pi.
So the amplitude was 0.030 lah.
Amplitude must be the same as this one. This is amplitude. That's where you get your antinode. Whereas for the node, we put your A equals to 0.
Okay.
Okay, we have finished. Anything you want to ask?
Nope.
Nothing to clarify.
Nothing to clarify. Now I understand better.
Okay, I hope so. From Friday, we will go to 21.
Yeah.
And Saturday, 22. If we can go faster, we go faster.
Yeah.
Okay, then. If not, have a good day.
Yeah, you too, Che. Next week, Monday and Tuesday, holiday lah, Che.
Up to you. If you still feel that you want a class, you let me know. You think through first.
Yeah, okay, I think can finish the entire past year book lah.
Okay, we'll stop here.
Yeah, sure. You stop here, Che.
You can think about it. If you want a class, you let me know.
Okay, sure, Che. Thank you, Che.